Welcome back, friends. In the previous session, we discussed about some of the examples in the roots law, and today we are going to start about a non-ideal solution. Remember, I told you that if you need these notes, you can visit Kipaji app and you can download these notes for use in your Android device. You can't get these notes in your computer. I'm sorry for that, but I know that even by this method you can copy or you can take some of the few important notes for your own review. Now, today we are going to start our discussion about a non-ideal solution. It will be very easier for you to understand my teachings if we pass through my videos of ideal solution, passing through the roots law, and when I will be talking about non-ideal solution, it will be easier for you to understand what do I talk about. Now, in defining ideal solution, we base it on the roots law. So the ideal solution is the one which obeys roots law, and the one whose components, if they are pure, they have the same intermolecular force of attraction as if they are in solution. Now, in non-ideal solution, we are saying that non-ideal solution is the solution formed from two immiscible solvents whose intermolecular force of attraction in the pure liquids are not equal to the intermolecular force of attraction in the solution, and the solution does not obey Roots law. So there are two basic things in defining non-ideal solution. The first basic thing is that it is made up of the immiscible liquids, immiscible solvents, and these immiscible solvents whose intermolecular forces of attraction, intermolecular forces of attraction in the pure liquids, whose intermolecular force of attraction in the pure liquids is not equal to the intermolecular force of attraction in the solution. And the second thing, this solution does not obey Roots law. So these are the two basic things you need to know about the non-ideal solution. First is the solution which is made up of the two immiscible solvents whose intermolecular force of attraction in the pure liquids is not equal to the intermolecular forces of attraction in the solution, and this solution does not obey Roots law. So it is very important for you to know about the Roots law, as I told you from our discussions regarding ideal solutions in the previous sessions. Now, consider the non-ideal solution which consists of two immiscible liquids A and B. Two immiscible liquids A and B. The intermolecular forces of attraction A will not be equal to intermolecular force of attraction B. Hence, the intermolecular force of attraction A and B will not be equal to intermolecular force of attraction AB. So this has two meanings. Let's say liquid A has a higher intermolecular force of attraction as compared with liquid B. Let's say liquid A has a higher intermolecular force of attraction as compared with liquid B. So what will be formed here, if this and this, they don't have the same intermolecular force of attraction, that means solution will not have the same intermolecular force of attraction as that of the solvents. So the intermolecular force of attraction in the solution will either be lower than all of these two. It will either be lower than that of B or will be higher than that of A. So if the intermolecular force of attraction will be higher than that of A, we'll call it the negative deviation. And if the intermolecular force of attraction will be lower than that of B, we'll call it the positive deviation. So non-ideal solution, they have either positive or negative deviation from ideal behavior. So ideal, when we call it as ideal, manake ni kama kitu kiko kwenye guideline fulani. This ni intermolecular force of attraction of A is equal to that of B. But in non-ideal solution, it can be either of positive deviation, or it can be of negative deviation. Now deviation, it is due to the partial vapor pressure developed above the solution. So if the partial vapor pressure developed above the solution is higher compared to that of the ideal, then this solution will regard it as it has positive deviation. Lakini kama vapor pressure ni ndogo, so vapor pressure ikiwa kubwa, yani it is higher, tunaita positive deviation. Vapor pressure ikiwa ndogo, yani it is lower, tunaita negative deviation. Hasa mnajaji kuwa ni kubwa au ni ndogo, tuna compare na nani? Na ideal solution. So vapor pressure, remember the vapor pressure is affected by intermolecular force of attraction. Vapor pressure is affected by intermolecular force of attraction. Why? It is because when you have the solution in the container like this, there will be molecules of solution, there will be molecules of solvent at the surface. And these molecules of the solvent, they tend to attract themselves. And this force of attraction between the molecules of the solvent, we call them the intermolecular force of attraction. That means the forces of attraction between the molecules. So the amount of vapor which will be formed above the solution will depend on the extent of escape of these molecules. The extent of escape of these molecules into vapor phase. If the intermolecular force of attraction in this solution, they are higher, that means the vapor formed will be lower. Why? Kwa sababu gani? Kutakuwa kunahitaji energy kubwa kuweza kubreak hizi bond kwenye higher intermolecular force of attraction, ili hizi molecules ziweze kuescape kwenda kwenye vapor phase. The vice versa is also true, that if the intermolecular force of attraction they are lower, that means the vapor formed will have higher vapor pressure. Because lower intermolecular force of attraction will require small amount of energy to break them and then to cause the escape of the molecules to vapor phase. So basing on that way, we'll have two types of ideal solution, that of positive deviation and that of negative deviation. So what we are saying ni kwamba kwa mfano hapa tunayo component A and B. The forces in the A and B, which is solution, they are not equal to AA and not equal to BB. AA is the pure solvent A and BB is the pure solvent B. Where this dash represent the intermolecular forces of attraction. So non-ideal solution does not obey Root's law. Over all concentration range at constant temperature. Does not obey Root's law over all concentration range at constant temperature. However, non-ideal solution may be converted to nearly ideal solution by making solution more dilute. So ukiongeza maji mengi, solution ikiwa more dilute, inakuwa ni nearly ideal, lakini sio ideal. Why the non-ideal solution becomes nearly ideal when the solution is more dilute? The reason is here. Because in a more dilute solution, there are more solvent interaction. Yani kama solvent yako ni water, kutakuwa kuna water interaction kubwa than solute interaction. So interaction kati ya solvent itakuwa kubwa kuliko solute. Hence, when non-ideal solution is made more dilute, the intermolecular force of attraction in the pure liquids become almost equal to the intermolecular force of attraction in the solution. Hence, ideal behavior is attained. Become almost equal, but not equal. Now, having known all of this and our discussion about the intermolecular force of attraction and the vapor pressure, as I will summarize in this paper, Let's move to the properties of non-ideal solution. First properties of non-ideal solution is that the intermolecular force of attraction in the pure solvent or liquids, they are not equal to the intermolecular force of attraction in the solution. We have already discussed this and we have already explained this in the few minutes before. The second behavior of non-ideal solution is about the pressure. The pressure of the solution is not the same or is not equal to the sum of the partial pressure of these. As I told you, it can be either higher or lower depending on the intermolecular forces of attraction. So if the pressure will be higher, that means it will be positive deviation. And if the pressure will be lower, that means it will be negative deviation from ideal behavior. The third property of a non-ideal solution is that its formation is accompanied with change in volume, such that there is concentration or expansion. There is either contraction or expansion. Why there is change in volume? It is because of the change in the intermolecular force of attraction. Remember, molecules of the substance, when they stay in a certain distance, they make that substance to have a certain volume. Now let's say the volume of the substance has increased. The volume of substance increased because of the decrease in the intermolecular force of attraction between the molecules of a substance. So if the intermolecular force of attraction between the molecules of the substance, they tend to increase, the volume will decrease. And if the intermolecular force of attraction, they tend to decrease, the volume will increase. Kwa vitu vinavyokuwa vinavutana, ile force of attraction inavyozidi increase, volume yake ina decrease. Lakini force of attraction inavyozidi decrease, ina decrease, volume yake also ina increase. So intermolecular force of attraction varies inversely proportional to the volume. Lakini pia property ya nne, its component cannot be separated by fractional distillation due to formation of azeotropic mixture. Azeotropic mixture. We'll discuss about azeotropic mixture, its formation, and how can we separate the components of azeotropic mixture into pure liquids. The fifth property, its formation is accompanied with change in heat. Change in heat. Why? It is because the energy used to break bonds and the energy used to make bonds, it is not the same. If you remember about thermochemistry, that in every kind of chemical reaction, there is bond breaking and bond making. So if we are breaking bonds and then we are breaking bonds which are weak, we are making bonds which are stronger as compared with the bonds which are broken down. That means at the end of the day, we'll end up with losing the heat, because formation of bonds is accompanied with the loss of heat. So that is the fifth property of non-ideal solution. Then the sixth property of non-ideal solution is that the boiling point of non-ideal solution, does not always in between the boiling point of the two liquids. Remember, in ideal solution, we said that if we have the boiling point of A, let's say it is temperature A, and the boiling point of B, it is temperature B, then the boiling point of the solution will be between these. Let's say this one is 8 and this one is 100. The boiling point will be in between. Let's say it is 90. But in non-ideal solution, the boiling point of the solution can either be lower than 80, let's say it is 70, or higher than 100, let's say it is 110. So this is different from the ideal behavior. So the boiling point of non-ideal solution does not always in between the boiling point of the pure liquids. It is either higher or lower than that of the pure liquids. This marks the end of our session. In the next session, we will start discussing about the classification of non-ideal solution. Remember, I have explained about the positive and negative deviation. So even in the classification part, we will be discussing about the positive and negative deviation from ideal behavior. So it is very important for you to pass through this session and to understand this before you are going to the second session. If you want these notes, go to the Kipaji app. You can get the notes very easier. Don't forget to subscribe the channel for more updates in chemistry, biology, physics, and mathematics. Thank you.